Alrighty, let's see what we got here. Looks like there was a part 2 from yesterday. Hard, find minimum and rotate sorted array. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array, this thing might be rotated 4 times. So yeah, so from yesterday, rotation is basically a shift leftwards by that amount, and then whatever shifts off the edge on the right goes back on the first entry on the left. And if the length of the array is divisible into the rotation, then obviously it's basically same as being unrotated, or same as the original array. Notice the rotating array is basically shifting left. Okay. Given the sorted array that may contain duplicates, return the minimum element of this array. You must decrease the overall operation steps as much as possible. Okay, so from yesterday, what I did yesterday was I needed to identify the breakpoint, the point where there's where the first and last part of the array, or the indices that are being looked at, is decreasing. But here it's duplicates, so it might not be easy to identify where it's decreasing. But still probably the same idea, I expect. So let's go ahead and take an example here. 0, 1, 4, 4. Let's do see, how do I make this hard on myself? 4, 5, 6, 6, and then 0, 4, 5, 6, 6, 6, 0, 1, 2. So I know the break is still occurring here because this thing is in the correct order, so therefore the break can't be there. Alright, let's just build the recursion function. So let's do define break. A and B are the indices of the portion of the array that I'm looking for. Return the value. Okay, so recursion functions always going to, you do those by building the base case first, generally, because the base case should be the non-recursive case that should have a straightforward answer in some fashion. So the base case here would be what? When would I not recurse? I guess if the first value and the last value, yeah, I guess if it's still the first value is less than or equal to the last value and within the indices, it doesn't recurse. So if nums at A is less than or equal to nums at B, then return the value at nums at A. Yeah, I think this was, if I'm somehow looking at just A and B as where 6 and 6 are, the lowest value there is still 6, right? I assume this is pretty, it's actually low acceptance rate. Okay, so if it does recurse, then somehow the first is bigger than the last, right? The first is bigger than the last. Then I think mid is equal to a plus b divided by 2. And then, I mean, what I did before was like just return like find break a to mid, or the minimum of this, versus finding the break if it's mid plus 1 to b, where a and b are inclusive. I do need to worry about whether or not this works. If it's a and b are the same spot, then that's fine. If a and b are one off, then a and b are one off, like adjacent indices, then that still should work. This would be a to a, and this would be b to b. So I think this might still work. So n is the length of, I guess I just return find break of from 0 to length of the nums array minus 1 as the last inclusive index. Okay. Passed more than half the cases before it stopped. Interesting. 313. So a and b are 0 and 2. Ah, I see. Okay, so I'm assuming that because the first and last were actually the same, that the middle were the same, but that's not true. Tricky. Very tricky. Probably should have caught that, to be honest. Probably should have caught that. Well, worth a shot. Okay, so this is the true, like, did they actually give me? Yeah, this wasn't really captured in the test cases, or the example cases. Okay. How to do this one. Oh boy, this one's really tricky. Like, that means it could be anything that is all the same except for one value. That's, so how would you find this needle in the haystack without actually looking through every value in the array? It's sorted, may contain duplicates. You must decrease the overall operation steps as much as possible. So it's not It's not saying it strictly has to be O of log n. Yeah, well, obviously this is going to affect the right. Well, like, I don't think you can actually 100% guarantee that. Yeah, I don't think you can get 100% guarantee that's log n runtime at this point. As in the worst case, this has to be O of n. Like, there's no way to find this without searching through everything, guaranteed anyways, in the worst case. So the question is how to minimize this kind of edge case, minimize the time cost of this edge case. Okay, so what if it was something like, what if there was a 4 somewhere? In which case this has to be 3, right? I guess 3, 4. Because it wouldn't work otherwise. So five, 3, 5. What am I trying to go here for? I guess so if there was another piece of information, like this is a 5, then the lowest has to be 3 at this point. Because anytime I see something that decreases that has to have a break, it's not like a hidden, it's not like the thing is hidden somehow there. So is it the case that if the first and last are the same and I haven't seen something higher, then I can't assume the things inside it are the same, so therefore I have to recurse. So maybe I just need to store a high value or low value. You can skip it if I see a high value. So store high value. It's really free. Hidden one somewhere. Or maybe a couple hidden ones. And maybe a hidden 2 in there as well. What do I do here? See, the first and last are the same, but they're also the same as my high value so far. So I have to do recursion. I have to do recursion. So maybe at this point when I see a 3 and a 2, I know that has to be somewhere in there. So is the edge case strictly if the whole array has the same first and last? Is it possible for the edge case to appear where the whole array doesn't have the same value first and last? I want to say no. So what do I do in that case? I just split it up? Or do I remove an element from the first and last and see? Or maybe remove the first and last element combined. Because the middle element has to be, the smaller element has to be somewhere in there. Yeah, maybe I just remove the first and last element at that point. Okay, I think that's what I'll try to do. N is the length of nums. Oh, but then I have to keep on doing it, huh? I have to keep on removing the first and last element at that point. Okay, I guess I could recurse just popping the first element. So this is the super edge case. So if b minus a plus 1 equals n, and nums at a equals nums at b, then if n is less than or equal to 2, then this is the only thing. Return nums at a. But if it's not, then I can do n minus equals 2, decrease it by 2, and then return find break of a plus 1, b minus 1. Okay, I think that might cover it. Cover the edge case. Okay, yeah. I guess I can just pass in n. And yeah, I think that works. Okay. Network error, what's going on? I wonder if my array's not working now. How odd. Okay, so that edge case worked. Oh my lord. Okay, okay. 112 or 121. I see. Okay, yeah, it could be higher or lower. I probably should have figured that one out too. Okay. So this returns this value. Okay, so this is just going to find the odd one out. So I think I just need to say min of nums at a or nums at 0. Probably nums at 0 could work here, but I could probably just use nums at a and whatever I find here, the odd one. Pretty sure this is fine. Nums at a. Okay. Okay. Interesting. Wonder how they tell whether or not this is too slow or too. Yeah, whether or not this is too slow. This is not a very long thing. I wonder if just doing minimum of the array is still going to give you a correct time. Okay, I don't know. Summary. What is the summary here? So very similar to yesterday's, with some additional handling of particular edge cases that would occur in this setup. So I guess so test cases 313 and 121. So this is modified my base case of the recursive function from yesterday to include handling for the two above test cases. Basically, if the array is kind of start and end, absolute start and absolute end, not just relative to not just the current indices, but are the same. This is possibly the worst case, as it might require searching through the whole array to find the singleton low or high value. If this doesn't occur, then the kind of breakpoint where the rotation kind of low, kind of high value precedes the low value in the order of the array. Rotation causes high value to precede the low value in the array. and the breakpoint can be found as normal. So yeah, it's basically in the worst case, I'm going to remove the first and last element from consideration. So ignoring the 3 and the 3, or ignoring the 1 and the 1, and try to find the thing in the middle. And then the thing in the middle could be the high or the low value, so I return the minimum of that thing in the middle versus just like the stuff on the side. Time complexity, this is going to be O of n in the worst case, where i.e. all values are the same except a singleton high or low value. That would need to basically be identified by going through all indices, In the typical case, where this doesn't occur, this will have the usual O of log n runtime. As it searches the array by kind of halves. Yeah, it splits up into two. If the half is already ordered, then it ignores it. If it's not, then it splits up further to find the breakpoint. Space complexity is going to be O1, since no extra space is needed. I'm surprised again that this was such a low acceptance rate, because I think this is one of the easier hard